In this lesson, we're going to talk about standard form of a linear equation. This is the third and final form of a linear equation that we're going to discuss this year in algebra. Okay, this lesson might take a little bit longer than normal because I'm going to walk through multiple ways to do each of these questions. And when I ask you these types of questions, you don't need to show me multiple forms, but I want to make sure that in the video here I can at least expose you to all the different ways that you can answer these, just for your own reference. So, standard form of a linear equation looks like this. The formula is ax plus by is equal to c. So if you have an equation in this form, you have a linear equation, which creates a line on your coordinate plane. Now, there are some stipulations that go along with standard form. A, B, and C must be integers, and A must be positive. So you have to keep that information in mind as you work through these problems. Okay, so the first one says determine the linear equation. So we're given the information that the slope is -3 and the y-intercept is 4. So what I'm going to do is I'm going to show you two different methods on how to do this, because at this point in time we understand slope-intercept form and point-slope form. So I'm going to show you how to do this by both angles. So let's go ahead and start with slope-intercept form. Let's go ahead and take the information and let's put it into slope-intercept form. And here's how. Y is equal to -3x plus 4. Now, the reason that I'm going about it this way is that you can't take information and substitute it into the formula. You just can't do that. You have to go one of these avenues in order to get the equation in standard form. So now that I have this slope-intercept form, I'm going to go ahead and transfer it into standard form. So I'm going to move my x over to the left-hand side by adding 3x to both sides. Now there's a little bit of literal equations getting involved here. So I'm going to say 3x plus y is equal to 4. Notice how I ordered my y and my 3x as such, 3x plus y, because the formula states ax plus by is equal to c. You have to have the x come first and then the y. So therefore, I'm finished. This is my equation in standard form. You can see that my a, my b, those are coefficients, and then c, my constant, are all integers. And you can also see that my a coefficient is positive. Therefore, I know I'm done. Okay, so that's kind of showing it from one angle. Now, I'm going to go ahead and change my pen color here, and I'm going to show you it from another angle. We'll use green. All right, now I'm going to show you it from the point-slope angle. So you can see that this given information gives me a slope of -3, and it also gives me a point. And we discussed this before, that my point is going to be my y-intercept, which is going to be 0, 4. Using that information, I can go ahead and plop it right into my point-slope form. So y minus 4 is equal to -3 times x minus 0. That's my point-slope form of my equation. Now I'm going to go ahead and transfer this into standard form. I'm going to start by distributing. Y minus 4 is equal to -3x, and then -3 times -0, well, that's not really a thing, so we're just going to leave it as is. Now let's go ahead and transfer it. I'm going to add 3x to both sides, and that's going to leave me with 3x plus y minus 4 is equal to 0. I'm running out of room, so I'm just going to go ahead and carry my work up here. I'm going to rewrite that statement right there. And then I'm going to show you my last step. I'm going to go ahead and add 4 to both sides, giving me 3x plus y is equal to 4. You can see that those two equations that either I solved using slope-intercept form or point-slope form are identical. So either way that you choose to do this is perfectly fine. Obviously, you can see that going through slope-intercept form is a lot less labor-intensive, but if you prefer using point-slope form, it's perfectly fine to do that. Okay, let me show you another one now. I'm going to show you this next one. Determine the linear equation given 2 points on the line. So I'm going to show you the avenue of slope-intercept form and then point-slope. So slope-intercept form first. Slope-intercept, you have to kind of think about this. We have to go back to when we learned about this. The first thing we need to do is find a slope. So let's go ahead and do that. Here's my x1, y1, and then my x2, y2. I'm going to go ahead and pop it right into my formula, which is -3 minus 1 divided by 1 minus 0, which is -4 over 1, which gives me -4. So my slope is going to be -4. If you remember correctly, this is what we refer to as the camel method. So what I want to do is I want to use the equation y equals mx plus b, and I want to substitute some values that I have. I'm going to go ahead and use the first point here. This is going to be my x and my y. So I'm going to substitute 1 in there. I'm going to substitute my slope in there. I'm going to substitute my x value in there, and then b is going to remain as b. I'm going to go ahead and solve it out. And you can see that my b is equal to 1. Now that I have a slope and I have a b, I can put my equation in slope-intercept form. So y equals -4x plus 1. This is going to be the line that's, oh, I didn't mean to box that. This is going to be the line that I'm going to use to put into standard form. But what I wanted to show you is that all it is a linear equation. So now let's go ahead and put it into standard form. I'm going to go ahead and add 4x to both sides. So now I have 4x plus y is equal to 1. And there I have it. There is my standard form of my equation. My a, b, and c are integers, and my a is positive. So that's one way to do it. Now I'm going to take you to the point slope method on how to do it. Again, all you need to choose is one of these methods. So point slope. Well, from the original problem, we already had a slope, right? We said that the slope, using our slope formula, was -4. So we're done with that piece. Now, choose a point. I'm going to go ahead and, just to make things interesting, I'm going to go ahead and choose that second point. I'm going to choose 1, -3. And I'm going to go ahead and pop it right into my point slope form. So I have y plus 3, remember that negative rule, equals -4 times x minus 1. There's my point slope form of my linear equation. Now, let's go ahead and transfer it. I'm going to start by distributing. Be careful with your negatives. And then I'm going to manipulate my x. I'm going to go ahead and move him over to the left-hand side. So now I have 4x plus y plus 3 is equal to 4. Now, I'm going to go ahead and I'm going to subtract 3 from both sides to get my constants together to leave me with 4x plus y is equal to 1. Notice how my equations are identical. It happened the same way. All we did was use a different method on how to get there. Now, I do want to indicate this. This is kind of interesting. But you see that not only do I have my standard form of my linear equation, but I have my slope-intercept, and I have my point slope. All three of these, I'm going to do a little triangle, are identical lines. We're just transferring them from one to the other. Okay, now let's go ahead and see what it looks like when we put it on a graph. So I'm going to go back to my pink pen here. It says determine the linear equation given a graph. Again, 2 ways to do this. Let's start with slope-intercept form. I'm going to go ahead and write this in slope-intercept form. So I need a slope. Oops. Don't know what that line was all about. Let's try that again. So I need a slope, and I need a y-intercept. I see my y-intercept is -1. That's really easy to identify, but let's see what my slope is. Looks like my rise is 3, and then 1, 2, 3, 4, 5, 6. My run is 6. So that's going to give me 3 over 6, which is going to give me 1/2 as my slope. So my slope-intercept form, remember I have to go that avenue. I have to do y equals 1/2 x minus 1. Now I'm going to take that and I'm going to transfer it into standard form. So let's go ahead and do that. I'm going to subtract -1/2 x from both sides. And please do show all of your steps for this. Alrighty. Now, this is kind of a new concept here, so you really want to pay careful attention. Notice how my a is not only negative, but it's a fraction. Well, I want to eliminate both of those pieces. So what I'm going to do is I'm actually going to do it in a different color here. Let's choose this pretty blue. Okay, I am going to multiply each side of my equation by -2. I did that because I not only want to get rid of the negative, but I want to get rid of the 2 in the denominator. Now, the tricky part of this concept right here is when you distribute. When I distribute, you can see that what's going to happen in the first term is it's just going to turn out 1x, or just plain old x. When I distribute -2 into y, that's going to leave me with -2y. And then, of course, on the other side is 2. What happens most often is that we eliminate that fraction and negative, but we forget about this component here. We have to distribute him in. And the way that I would remember this is I would always use parentheses. Just like I always stress to use parentheses, that will remind you to distribute that -2 into both terms. And of course, don't forget to do it on the other side as well. All right, now we're in standard form. Okay, so that's one way to do it. Now, you probably are thinking, I know how to do it the other way because we've been doing it this way. Let's go ahead and do this in point-slope form. I'm going to go ahead and just choose one of these points. I'm going to go ahead and choose this point. So I know that my slope here is 1/2, and that coordinate is 4, 1. Okay, that's my x1 and y1. So let's go pop it into my point-slope formula. Y minus 1 equals 1/2 times x minus 4. Perfect. Now, let's go ahead and distribute. So I have y minus 1 equals 1/2 x. Be careful here. 1/2 times -4 is going to give me -2. Now go ahead and dabble and move things around. So I'm actually going to move my constant over first. I'm going to go ahead and add 1 to both sides. And so I'm left with y is equal to 1/2 x. And that's going to be -1. And then the last thing I'm going to do, I'm going to go ahead and move my x over. You can see what that's going to do. It's going to create a fraction. So I have -1/2 x plus y is equal to -1. Same thing is occurring here. So I'm going to go grab that pretty blue color. And I need to eliminate that number. So I need to multiply both sides by -2. It is just a coincidence here in this situation that's -2. It's not always going to be -2. And that's going to leave me with a final answer of x minus 2y is equal to 2. Just like we got in the original problem we did. So we should get the same answer here because it's the same line. But I wanted to show it to you from both angles. So you can pick which one that you like to work with better. Okay, let's go ahead now and let's look at our special graphs. We've been talking about these special graphs now for a while, so let's go ahead and see what they are. The first graph here is a vertical line, which, of course, in standard form is going to look just like it always does. X is equal to 1 because its x value is right on that 1. And then standard form of a horizontal line is going to be y equals 1 because our y value is crossing the y-axis at 1. Again, anytime you have those special graphs, they never change. They're always going to be x equals and y equals. Okay, now I want to show you how to graph it, and this is really cool because this is going to go back to a concept that we talked about a little while ago with intercepts. So it says graph the linear equation, and there's 2 ways to do this. So here is the first way. I'm going to go back to what we talked about with intercepts. Do you remember when we graphed x and y intercepts? If you remember correctly, when you're looking for the x-intercept, you're going to substitute 0 in for y. And when you're looking for the y-intercept, you're going to substitute 0 in for x. So let's go ahead and do that. So let's go ahead and find the x-intercept first. I'm going to go ahead and substitute my 0 in for y right into this equation. You can see what that does. And you probably remember doing this a long time ago, and now you can see where it applies. So I'm just going to solve this equation down to get x is equal to -3. Okay, So that is going to be where my x is going to, it's going to cross my x-axis. Now I'm going to go ahead and find my y-intercept. Same idea. This time I'm going to substitute 0 in for x. That's going to leave me with 3y equals negative 12. And I'm going to divide both sides by 3. And y is going to equal negative 4. So my y is negative 4. That's going to look just like this. Once you have those two intercepts, what you can do is you can just do this. Connect your dots, draw your line, draw your arrows, and you have your linear equation. So that's the first method on what you can do to solve this type of problem. Now, I'm running out of space here, but I want to show you another way that you might prefer doing it. I think I can squeeze it in right over here, actually. So, let's see here. I'm going to go ahead and rewrite it as 4x plus 3y is equal to negative 12. What I can do is I can transfer this into slope-intercept form and graph it. So I'm going to go ahead and do that. I'm going to subtract 4x from both sides of the equation. And I'm going to have 3y is equal to negative 4x minus 12. You can see why I wrote those terms in that order, because it's in the form of slope-intercept form. And then I'm going to go ahead and I'm going to simply divide both sides by 3. Alrighty, that's going to leave me with y equals negative 4/3 x minus 4. And I got the 4/3 by, remember the little butterfly property that I showed you? Remember the little butterfly? Yep, he's popping up again too. So this is going to be my equation in slope-intercept form, which, as you can see, is actually the graph that we drew. So there's two ways to do this. You can do it using the intercepts, or you can do it by transferring into slope-intercept form. Okay, last thing we're going to do today is we're going to do some more transferring. Now, let's go ahead and practice transferring it from point slope to standard, because this is going to be a really important skill we're going to use quite a bit this year. So let's go ahead and practice this. I'm going to start by distributing. So I'm going to say y plus 1 is equal to 1/2 x. Now this part is really important. 1/2 times negative 4 is going to leave me with negative 2. I like to personally move my constant over just to kind of get him out of the way. And then I'm going to move my x. Of course, with the constant. Oh, I'm sorry, that's a minus sign. Whoops. He's positive originally, so of course I need to subtract him. That could have been a major error there that I made. All right, here we go. So now I have negative 1/2 x plus y is equal to negative 3. Now we're in that same situation again, and I'm going to use that blue pen to remind us that we're going to multiply both sides of the equation by that number that's in the denominator with that negative. Sometimes there's not a negative right there, so you'll just multiply it by 2. It just depends on what's really there. So I'm going to multiply this one by negative 2 to eliminate the negative and the 2, and I'm going to do that on both sides. That's going to leave me with an answer of x minus 2y equals 6. And I'm done. I am in standard form. Okay. The last one I really like, because this happens a lot. Sometimes you end up with a situation where you have an equation that is linear, but it's not in any particular form. So it's not in slope-intercept, it's not in point slope, and it's not in standard. So it's just no specific form. But we want to take it and put it into standard form. So let's go ahead and do that. It kind of looks like it's getting to standard because you can see that I have the ax plus by equals c. But I have a fraction and I have a negative, so I can't have that. I'm going to start by eliminating the fraction. To do that, I'm going to go ahead and I'm going to use that blue pen again, and I'm going to eliminate the 2 in the denominator. To get rid of him, I'm going to multiply him by 2. Now, technically, I can multiply him by negative 2, but I'm going to do this thing in 2 steps so you can see what's happening. So now I have negative 6x plus y, because those 2's are going to cancel out, is equal to 8. Remember, that 2 is being distributed into both of those terms. Now, to finish this off, you can see that I have a negative as my a coefficient. Can't have that. So I'm going to multiply both sides again by -1. And that's going to eliminate it because a negative times a negative is a positive. That's going to leave me with 6x minus y. Be really careful. You have to distribute into both pieces. Equals -8. And I'm done. Okay, that brings us to the end of standard form. I know that was a little bit of a long video, but I wanted to show you both of those methods on how to solve each one of these problems. So feel free to go back and look at this at your own pace.